All right. So we have talked about Bitcoin for weeks. Now it is time to talk about alternative coins. So we continue to the topic of cryptocurrencies, and we will talk about anything, any cryptocurrency other than the Bitcoin. So that is actually my definition of an alternative cryptocurrency. Okay. So sometimes people use alternative coin in a negative way, but actually we are actually we say alternative coin to the any cryptocurrency that is other than Bitcoin. Okay, so the invention of Bitcoin led the way for other cryptocurrencies. Since we realized that we can have a cryptocurrency, some people said that why don't we have other cryptocurrencies? So thousands of similar Bitcoin-like cryptocurrencies were introduced to be the next Bitcoin. So their aim was to be the second biggest or maybe take the place of Bitcoin. But initially, most of them use Bitcoin source code. So they actually borrowed many source code from Bitcoin because it is actually very hard to write this kind of codes. If you already check the GitHub, you can see that, you know, Bitcoin or Ethereum source codes are really actually hard to implement, and it's you have to be sure because there may be some security issues, especially for the cryptographic algorithms. You have to be sure that you implemented them correctly. So this is why actually this is why most of the other cryptocurrencies use the same elliptic curve with Bitcoin, because you just copy pasted the code. Okay, so although people created a lot of coins, actually we can also create a coin in a second. We can, you know, just copy the Bitcoin and create a hard fork, or we can build a coin from the scratch. It is very easy. So there's no limit on alternative coins, but hundreds of cryptocurrencies died due to many reasons. For instance, people lost interest of the coin. So most users stopped using that coin, and sometimes miners lost the interest because they realized that mining that cryptocurrency is not that profitable. So they use their devices, GPUs or ASICs, to mine other cryptocurrencies. So these cryptocurrencies reached to a block number where it stopped there. You know, so this is one of the reasons why they die. And some of them died due to software bugs. And this happens a lot, especially there in the wallets software. If there are some bugs, you know, you can lose cryptocurrencies, and people, you know, lose interest when they lose their cryptocurrencies. And actually, some software bugs also appeared in mining algorithms. So some people attack the cryptocurrency due to these bugs. So as I told you before, implementing cryptographic algorithms are not that easy. Many software implementers are not proficient in this area. This is why when you create a new cryptocurrency, most of the time you change the mining algorithm. So you have to implement it from the scratch. And this is why some software bugs allow attackers to, you know, gain the dominance in the mining and so on. So the software bugs actually can happen in any part of the project. The 51% attack happened to many cryptocurrencies. This is a huge issue because in order for a cryptocurrency to have trust, you know, it shouldn't receive this kind of attacks. But when more than half of the miners gain control, you know, they can perform this kind of attack. So for instance, in Bitcoin, we said that the miners wouldn't do that because since they are earning money from that cryptocurrency, performing such an attack would be bad for them because they will lose their money at the end because the price of the Bitcoin will be lower and people will stop using that Bitcoin. So although we can have this argument for the top cryptocurrency, you can have this kind of attacks in the middle or lower cryptocurrencies because, you know, assume that you are mining Ethereum, you have a lot of GPUs, and you realize that there is a cryptocurrency where there are a very small number of miners. So for a few hours, you can stop mining Ethereum and come here, you know, mine that cryptocurrency. But in the meantime, you know, create a parallel blockchain where you mine in a different way. You sell your cryptocurrencies in this block, but you go to the parallel one and say that this is longer and perform the 51% attack. Okay, so recall how the 51% attack worked. Okay, so if you have more than half of the mining power, you can secretly mine in a different way by causing a conflict, and you convince that the main blockchain is the longest one. You sell or buy there, but then announce that there is a longer blockchain, so all of the blocks since the conflict actually didn't happen. So this is one of the reasons why some cryptocurrencies have 51% attack. So for this reason, most of the time alternative currencies do not use the same mining algorithm with top cryptocurrencies like Bitcoin or Ethereum, because people with ASICs may stop mining those currencies and come and perform mining in your cryptocurrency and perform this kind of attack. So there were also some cryptographic weaknesses in the mining algorithms and so on. So this was also the reason for some of the cryptocurrencies to die. So a cryptocurrency may die for many reasons, as you can see, and I think more than 1,000 of cryptocurrencies died since the invention of Bitcoin. So then the question arises, why would we have a Bitcoin alternative? So isn't it one cryptocurrency enough, right? So there are many reasons to introduce a Bitcoin alternative, and let me mention them in a list here, then explain why there might be good reasons to do that. So one of the reasons is higher coin cap, faster transactions, coin introduction rate, more transactions per second, smaller transaction fees, GPU-friendly mining, and scripting language with more capabilities. So you can introduce an alternative cryptocurrency which has these properties that are different than the Bitcoin. Okay, so people in the last 13 years introduced a lot of cryptocurrencies where they modified the Bitcoin code in terms of these properties and obtain a different cryptocurrency in the hopes of being the second Bitcoin. Okay, so let's look at them one by one. So the total Bitcoin amount is fixed to 21 million in Bitcoin, but it is actually very slightly less than 21 million, but this is negligible, so that it is not that important. So this causes a effect in the price of Bitcoin. So people thought that the scarcity of the Bitcoin actually results in high prices. So maybe we can, increase the number of coins so that this way our cryptocurrency will be cheaper. But this way, a lot of people can, use it in daily life. So although we have 21 million cap in Bitcoin and currently 19 million of them are mined, so actually we have a lot of Bitcoin in circulation, but actually circulating Bitcoin is much less than 19 million due to the burned Bitcoins. Some people burned their Bitcoin just to prove a point, but actually they are gone, so you cannot use them again. Some people lost their private keys, so they cannot recover their Bitcoins. So from the early days of Bitcoin, a lot of people lost their private keys. And also people sent Bitcoin to wrong pay-to-script hash addresses, and you cannot recover them if you cannot solve the discrete logarithm problem for the elliptic curves. Okay, so all of the coins sent lost in these ways are completely lost. So we don't know the exact amount because we don't know how many people lost their private keys. But currently there are only a few million Bitcoin actually in circulation. So many alternative cryptocurrencies have higher supply limits. So most of them use a cap larger than 21 million. And some alternative cryptocurrencies actually have no supply limit. For instance, in Ethereum, you don't have a limit. So we don't know when they will stop adding new Ethereum. Maybe they will not. Okay, so this limit actually depends one of the criteria of your cryptocurrency design, because it directly affects the price of the cryptocurrency. Okay, so most of them use a cap larger than 21 million, or maybe they don't use any upper limit at all. So second reason is faster transactions. So recall Bitcoin block addition time is 10 minutes. So, but of course, it doesn't mean that your transaction will happen in 10 minutes. Maybe you will pay small fee, so it will delay for the next block. So you can wait maybe 20 or 30 minutes for it to be included in the blockchain. But even if it is included, there might be a conflict. So we say that you should maybe wait for 6 blocks to be sure that it is really included in the blockchain. But if you wait for 6 blocks, this is in average equals to 60 minutes. So you have to wait for 1 hour to be sure that the transaction is included in the blockchain. So many alternative currencies said that this is a long amount of time. You cannot go to a bar and get a beer and, pay it with Bitcoin and wait for an hour, right? Or get your pizza and wait for the transaction to be included in the blockchain, and 6 more blocks are added on top of that, right? So this is why people change this block addition time. And moreover, this is for small transactions for maximum safety for the Bitcoin. It is recommended that for the irreversible sale of items with value comparable to the block reward, a large number of confirmations, like 144 blocks, which equals to 1 day, is required before completing a Bitcoin exchange. So if you want to transfer huge amounts of Bitcoin, we suggest you to wait for 1 day to be sure that it is really happened. So such long waiting times prevent Bitcoin to be used as fast payments. This is why actually you cannot use Bitcoin in a supermarket and so on, right? In daily life, you cannot wait this amount of time. So almost every alternative cryptocurrency have average block addition time less than 10 minutes, some as small as 5 seconds. So in Ethereum, this is like 12 seconds, sometimes between 12 to 20. So this is why people introduce new cryptocurrencies, so that they thought that Bitcoin will be used for a large amount of transactions, large in terms of money, but for smaller transactions, they said that you can use our cryptocurrency. So this is one of the reasons why people introduce new cryptocurrencies. Third reason for introducing an alternative coin is the coin introduction rate. So recall that Bitcoin introduction rate is halved in every 4 years. So initially, the reward was 50 Bitcoins. So almost in every 4 years, this is halved. And currently, the reward is 6.250. But in 2024, we are expecting another halving around March. So the reward will be halved. So this halving actually causes some hype, because when the halving happens, the miners spend the same amount of electricity, but their rewards are halved, right? So people think that this might increase the prices. So this causes a hype. So some alternative coins thought that maybe we should do the halving more frequently instead of 4 years. So this way we would cause hype more frequently. So some alternative cryptocurrencies have halving in every 1 to 2 years, because halving sometimes causes a hype. Some alternative cryptocurrencies use fixed coin introduction rates, so they don't actually have halving at all. So actually we can say this for Ethereum, but we will talk more in Ethereum mining. And actually, if they achieve the proof of stake transaction, it will be like also triple halving. So I will talk more about it when we talk about Ethereum. But in Ethereum, currently the coin introduction rate is fixed. But since they upgrade the Ethereum a few times in a year, they may change it, because they change it a lot. Initially, it was 5 Ethereum, they reduced it to 2, and now it is, they reduced from 5 to 3, but now it is 2. And when they move on to proof of stake, it will be much more different. So fourth reason is to have more transactions per second. Due to the block addition size and block addition time and block size, we talked that Bitcoin guarantees around 5 transactions per second. So this value actually depends on the block addition time and the block size. So you can modify block size. So if you increase the block size like Bitcoin Cash, you can actually guarantee more transactions per second. Or you can also reduce the block addition time by keeping the block size fixed. So this way you also can guarantee more transactions per second. So some alternative cryptocurrencies reduce block addition time to increase transactions per second. And so almost every alternative cryptocurrency actually has a block addition time less than 10 minutes. Some alternative cryptocurrencies increase block size to increase transactions per second. So this is what Bitcoin Cash did. And some alternative cryptocurrencies actually do the both. Now you have shorter block addition time and larger block size. So this way you can guarantee more transactions per second. But still, we are talking about hundreds of thousands of transactions per day. So compared to other payment systems or blockchains like Stellar, where you can have around 9 million transactions per day, these are really small numbers because these are permissionless blockchains where the mining takes most of the time. Okay. So fifth reason, smaller transaction fees. Bitcoin transaction fees depend on the network demand and Bitcoin price. So recall that you can even create a transaction where you don't pay any fee, but miners would not include your transaction because they're not earning anything. So you have to pay some transaction fee. And if the network demand is huge, you have to pay more to be included in the block, right? Because miners always choose the person who pays more Satoshi per byte. So this depends on the network demand. So for example, transferring $5 worth Bitcoin may require $5 or $50 worth Bitcoin transaction fee, depending on the current price of the Bitcoin. So this makes it hard to use in daily life for small purchases, right? You cannot pay a few dollars to a pizza and then, pay $50 of transaction fees. So that is the idea. Okay. So some alternative cryptocurrencies require very small amount of transaction fee, but this may also encourage selfish miners to avoid including these transactions in a block. So you have to choose it in a very clever way so that, including that transaction would still be beneficial for the miner so that they would include it in your system. So most of the time, the transaction fees are less than the transaction fees of Bitcoin. But again, if the price of a cryptocurrency increases a lot, this may be not correct. Okay. And the sixth reason, GPU-friendly mining. So Bitcoin mining is based on double SHA-256 computation, which requires almost negligible memory, right? You're purely performing logic operations to perform SHA-256. So GPUs cannot compete with ASICs in Bitcoin mining because FPGAs, when they are burned into silicon, they became dedicated devices, and these devices can perform these logical operations a lot faster than GPUs, and they would consume less electricity than GPUs. So this is why currently you cannot mine Bitcoin using a GPU or a CPU, right? Even FPGAs cannot compete with ASICs. So initially, people were mining with CPUs like Satoshi did. Then GPUs became general purpose computation devices. So people start mining with GPUs. But this era ended when people built dedicated devices. So GPU miners got a little bit angry and they actually wanted to continue mining. This is why they look for alternative currencies to mine. Okay. So some alternative cryptocurrencies like Litecoin, which was introduced in 2011, just 2 years after Bitcoin, and this was actually the second largest cryptocurrency at the time. in terms of market cap actually, and they promised ASIC resistant mining algorithm. Okay, so although they did that, currently this promise is not correct, and they accept that they failed in this respect. So many ASICs were built in the past for mining algorithms that were claimed to be ASIC resistant. So let's look at Litecoin's mining algorithm. So they use Scrypt, and actually Scrypt wasn't designed for mining. It is actually for, you know, password-based key derivation and so on. So this is an algorithm to slow down, you know, this process. So people thought that it is a nice way to use in mining. So this, because this is memory intensive, and, you know, people thought that if you have an algorithm that is memory intensive or memory hard, building an ASIC would be costly, and, you know, they will be slow. So this is why people try to come up with memory intensive algorithms. So Scrypt is one example. But when you use the Scrypt algorithm, you choose a few parameters. Okay, but for the Litecoin parameters, people build ASICs. Okay, so the question is, why don't they change the parameters so that, you know, create a hard fork and make it ASIC resistant? So one can modify Scrypt parameters to prevent building efficient ASICs, but this also makes mining solution verification inefficient. So let's recall the Bitcoin mining algorithm. You know, we try to make it to solve the hash puzzle hard that it will take like 10 minutes. But even somebody solves the problem in 10 minutes, verifying the solution takes only microseconds or a few seconds, right? You can verify it in a very fast way. So if you modify Scrypt parameters, it will be harder to solve, but verification also gets slower. This is why actually Litecoin failed to make Scrypt ASIC resistant. They can actually make it ASIC resistant, but this will give a latency to all of the transactions and block additions. Okay. So there are ASICs for Ethereum's ETH mining algorithm, but GPU miners also profit from mining Ethereum. This is because the price of the Ethereum is really high, and compared to ASIC's performance, mining with GPU also profitable. So currently, most of the GPU miners are mining Ethereum because it is more profitable. But when they transition from, they make a transition from proof of work to proof of stake, these ASICs for Ethereum actually will be useless, right? But GPU miners can move on to a different algorithm and continue mining. So we will talk about it more when we talk about Ethereum. So since Scrypt failed, a lot of cryptocurrencies tried to come up with hash algorithms that are ASIC resistant. So people thought that since for the ASIC build, people have to optimize the algorithm for the ASIC, right? For the FPGA. So they thought that if we use a lot of algorithms, they have to optimize all of them. So it will be harder to build an ASIC. It will take more years to come up with a good solution. So some cryptocurrencies suggest us to use multiple hash functions. So it started with X11. So they went to the SHA-3 competition and looked algorithms from there. They looked at the finalists, you know, or eliminated in the second round and so on. So they chose 11 algorithms from SHA-3 competition. Ketchak is the winner. So they actually, their mining algorithm is the consecutive use of these 11 algorithms, and the result should be lower than some value, like in the case of Bitcoin double SHA-256. But instead of double SHA-256, you use all of these 11 algorithms consecutively. Okay, so people thought that this would be ASIC resistant, but very efficient ASICs were built for X11. So they said that let's add more algorithms. Instead of 11, use 13 algorithms. So this time we also have HAMC. And again, it took some time, but efficient ASICs were built. So they said that let's increase it more. They added 2 more algorithms. They added SHA-512 to these 15 to obtain the 16 algorithms. Then they said that, okay, maybe we should randomize it. the order of these 16 algorithms should depend on the previous solution, right? So this way, building ASIC will be even harder because the order of the algorithm use will be different. Then finally, they introduce X17. I don't know if there are any ASICs for this, but if it were profitable, people would, try to build such an ASIC and sell it. Okay, but I know that there are ASICs for X11 and X13 and so on. Right. So the last reason I said that for introduction of alternative coins were scripting language with more capabilities. So recall that Bitcoin scripting language is a sequential language simply called script. So this is a sequential language. So you write it from top to bottom and you perform all of the operations from top to bottom, right? So they deliberately avoided for or while loops. You cannot have loops in Bitcoin because if you write a loop in a bad way, this will cause an infinite loop, right? So they thought that since when you perform a transaction, all of the miners actually perform that operation, that transaction, you can introduce infinite loops and cause denial of service attacks for these miners. So this is why they kept it simple. So they had a simple scripting language to perform operations on the Bitcoin blockchain. So it is very limited in terms of programming. This means that you cannot do everything like you can do in a language like C, Python, or other popular languages. So the technical term here is that it is not Turing complete. But in easier way, we can say that you cannot do everything. That is the idea. But Ethereum's scripting language Solidity is an object-oriented programming language that is Turing complete. So this was a different approach by introducing a different cryptocurrency, but this time the scripting language is somewhat different. And since it is Turing complete, actually you can do pretty much anything, right? So Solidity makes it possible to create and run decentralized applications and smart contracts. So this is why it is popular these days, and this is why it kind of is a way to Web3 or metaverse. So this is why there's a huge hype about this. This is why people are writing smart contracts for Ethereum blockchain. But we will talk about this in the Ethereum topic. But smart contracts, are larger transactions compared to simply sending Ethereum to somebody. So they actually consume a lot of resources, so you have to pay a lot of transaction fees to do that. Also, you can say that you can ask here, if Bitcoin avoided infinite loops, why Ethereum is making it possible to create an infinite loop, right? So Ethereum takes the problem in a different way. So when you create a transaction, you also pay some fees, like gas fee. So that gas fee actually allows you that amount of computation. So whenever you create a transaction, you actually look at the instructions you write there and you actually understand how much gas it will require for you so that the miners would run it. So you can create an infinite loop, pay as much as gas you want, but the miners will run that transaction. But when you run out of gas, they will, stop and break that infinite loop. That is why having a Turing complete language here doesn't cause an infinite loop, because miners know when to stop. Okay.